Hi everyone, it's Sorkin. Today we have a problem when we are given n cities. So for example, in this case, we have 4 cities, 0, 1, 2, and 3. So what we need to do, we need to return the city with the smallest number of the cities reachable through some path, whose distance is at most our threshold distance. So for example, in this case, we have, let's say that the city 0, right? City 0 is reachable from city 1, city 1 and the city 2, and it's not reachable from city 3 because in this case that it's more than the threshold distance threshold, which is 4. So and the city 1 is reachable from the city 3, city 3, city 0, and the city 2. So it's reachable from 0, 2, and 3. The same way is 2 is reachable from 0, 1, and 3, and 3 is reachable from where? 3 is reachable from 2 and from 1. It's not reachable from 0 because in this case it's more than the threshold distance, which is 1 and 2, right? And in our case, we need to return the city with the minimum, with the smaller number of cities reachable. So which means that we need to return either 0 or we need to return 3. So in this case, we are going to return 3 because if there are multiple such cities, return the city with the greatest number, and the greatest number in this case is 3, so we are returning 3 here. We are going to use Floyd Warshall algorithm to solve this problem because we need to find the shortest distance between every city, right? So for example, in this case, the shortest distance between 0 and 1, between 1 and 2, and so on. So let's remind ourselves how exactly we are implementing Floyd Warshall algorithm. So in our case, we are creating a matrix 2-dimensional array, let's call it graph, with the size being the n-to-n, the number of the cities, the number of the vertices, right? And the first we are updating the edges that we have. So for example, going from 0 and 1, the distance is 3. And again, if they're going from 0 to 1, the distance is 3. Going from 1 to 0, the distance also 3. And the same for going from 1 to 2. From 1 to 2, the distance is 1. Going from 2 to 1, the distance also 1. Going from 1 to 3, distance is 4, and from 3 to 1, distance is 4, and the last one is 2 to 3 is equals to 1, and for the from the 3 to 2 also equals to 1. And from the city to itself, which means that from 0 to 0, we are setting these values to 0. And for all other distances with that we don't have direct connection, right? So for example, from 0 to 2, we are setting all these values to infinity for as we start. So that's our first approach. The next is that we are going over each case going from 0 to 2, right? So we are checking, for example, for 0, right? Can we go from 0 to 2? Is it shorter for us to go from 3 or maybe go from 1? So for example, in this case, there is from 0 to 2, the distance is infinity, right? And at each step, what we do, we are checking again for each node. For k nodes, we are doing that for each node, right? So we are checking that can we go from 0 to 2? So for example, going from 0 to 2 is the infinity, so we are taking at each step we are taking the minimum value, right? So going from 0 to 2, the value is infinity, and so what if we will go from 0 to 2 from 1, from the node 1, right? Going from 0 to 1, the value is what? The value is 3 plus going from 1 to 2, the value is 2, and the value is 1, gives us what? Gives us 4. So 4 is less than infinity, so we are updating the value for 0 and the 2. We are updating this value to 4. Again, from 0 to 2, the value is 4, and from 2 to 0, the value is also 4, right? So we are updating this value, and we are doing that the k number of times. So for example, going from 0 to 1 from the 0 to 2 from the first node or the second node, and we are taking that minimum. So we have 3 for loops here, and the time complexity of the Floyd Warshall algorithm is of n squared, right? Because we have 3 for loops here. That is the first part. That is we are implementing Floyd Warshall algorithm, and now in our matrix, in our two-dimensional array, we have the shortest distance between every CD. So that's the first part. What's the second part? Second part is that we need to find a minimum CD, right? The CD with the minimum connections. So for example, in this case, what we do, we are going over each CD, for example, CD 0, and we are checking that for the CD 0, if how many CDs we have with the distance being that less than our distance threshold. So for example, in this case, it's 2. So right, if we are starting first with the 0. For the 0, it's 2, because going from 0 to 1, it's going to be what, 3, 2, and this distance is 7. So we are not considering this one because it's more than our threshold distance. So we are taking 2. So we are going to have here variable minimum CD, right? Minimum CDs, and we will keep updating that. So we are updating. So for the first one, it's 2 for the first one. So we are in our result, right? We are setting the I, which is the value. The I meaning that for example, in this case, I is equals to 0. Now again, our minimum CDs is equals to here to what? Our minimum CDs is equals to 2. The next one, we are going to the next one. Next one we are checking. So in this case, for 1, we have 3 connections, right? We have 3 connections, which is less than 4 or equals to 4, so which means that we are not considering that. We are going to the next one. 2 has because we need to find the CD with the minimum connections. So 2 has also 3 connections, which is less than or equals to 4. We are skipping that, and the last one also 3, right? For the 3 is we have 2 CDs. For the 0, it's 7 again. For the 0, it's 7. From going from 0 to 3, it's 7. So we have only 2 CDs, which is less than or equal to 4, right? Which is less than or equal to 4. So in this case, again, we are setting our result to I, we are setting to 3, and we are returning that because we need to return that the greatest value if we have 2 CDs with the same connection. So for example, in this case, 0 and 3 have both 2 connections, 2 paths, which is less than or equal to 4, right? And we need to return 4. So in this case, we are setting our I to our result to I, which is 3, and we are returning that. First thing that we do here, we are creating a two-dimensional array, our matrix graph, where we are going to store all the distances. And the next step is we are going, and as a first step, we are setting the values from CD to itself. For example, from 0 to 0, from 1 to 1, we are setting to 0. And the rest of the matrix, we are filling with the infinity value. In our case, we are taking the integer max value for it. And the next step is we are going over our edges and populating our matrix. For example, let's say from city 0 to city 2, right? We are setting the distance here, and from 2 to 0, again, we are setting the distance. And the next step is we are implementing our Floyd Warshall algorithm. So what we do here, so let's say that we are doing for x and for every CD, let's say from CD 0 and 5, right? So we are checking that can we go from CD 0 and 5, from the CD 1, from the CD 2, from the CD 3, 4, and so on. So which distance could be shorter? Let's say that we are for the CD 0 and 5, we are checking when the k is equals to 3, right? We are checking that if the distance from CD 0 and 3 plus the distance from CD 3 and 5, and if that is less than, or if that is less than the direct distance from 0 and 5. If that is less than, then in that case we are updating the value. If any of these from 0 to 3 or 3 to 5 is equals to max value, which means the infinity, we are just skipping that, because in that case in that case the resulting value would be infinity, so so we are keeping the value as it is for the 0 and 5. So after exiting this for loop, we implemented our Floyd Warshall algorithm, and now we have shortest distance for between all CDs. So the next step is, and the last step that we do here, we are creating two variables, minimum CDs and the result. Result is we are setting by default to -1 and the CD to n+1, because for the -1, that if we won't find any result, we are just going to return that as a default. So we go over our two-dimensional array. What we do here, we are counting the distance from the CD to all other CDs, excluding the distance to itself. And if that distance is less than our distance threshold, so our threshold distance, so in that case we are incrementing our count. If after exiting this loop, if our count is less than our minimum CDs, so we are updating our minimum CD, right? We are maintaining this variable, and we are updating our result, and we are updating our result to I, right? Whatever the index is. For example, we are starting, in our case, in our previous example that we have seen, we have two cases, 0 and 3. So right, first we are going to update this value to 0, but we need to return, because 0 and 3 have the same distance, have the same number of CDs with the threshold distance, right? So, but we need to return 3. So in this case, the last one is, so first we are going to update this value result to 0, and the last one is we are going to update to 3, which we are going to return as a result. What's the time and space complexity of this solution? The time complexity is we have 1 for loop, 2 for loop, 3, 4 for loop, right? So, but this for loop determines our time complexity, because the time it's of n cube, so n cube, and since these all are less than the complexity of our n cube, so we are just disregarding these for loops, and we are taking the highest one, which is n cube. For the time complexity, for the space complexity is determined by our two-dimensional array, our matrix, which is the n square. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.